You can start, ma'am.
Okay, great. All right, so welcome to the third live session for competitive programming. Let me make sure that I'm muting my YouTube page so I don't get an echo. All right, so how is it going, everybody? I think we have 2 weeks worth of material that has been released by now, and I think week 3 will be available from Monday. In particular, the assignments will be available from Monday. I think you already have access to the videos. So, so how many of you, among those of you who are here on the live stream, how many of you have finished the programming assignments for week 1? Give me a +1 in the chat if you finished the programming assignments for week 1. Okay. All right, you're working on the divisor problem. Okay, you have ongoing lectures. Right. I think the deadline for the assignment is in the future, right? I think that's something that I checked a couple of days ago, and that prevents us from actually discussing the assignments during this live session, unfortunately. Typically in the live sessions, what we do is we discuss assignments whose deadlines are just finished so that we can go over them together. But that's something that we won't be able to do until next week, I guess. Yeah, so that's right, Tejas. So I think we'll be able to pick this up next week. But all right, so so what programming languages are you all coding in? Is it Python or C++ or Java or something else? Can everybody maybe share your choice of programming language? Srinivas, no, week 0 submission is not mandatory. So it's just for you to get a sense of, it's an ungraded assignment. And we also, I think in most weeks, we also have like these practice problems. So you don't have to submit them or anything, or at least they're not graded. But it sort of gives you a sense of your preparedness for the course, yeah? All right, so a couple of you on Python and then C++, and Alan, you're switching from Python to C++. Yeah, comfortable with Python because writing code feels faster. That's true. If you are already kind of comfortable with a particular language, it comes more naturally to you. Then yeah, at least, especially if you're doing a contest, I think it makes sense to code in the language that you are probably fastest typing at. You're going to switch to C++ this semester. Okay. That's always exciting, though. I mean, C++ is, I think, is an extremely popular language choice in the context of competitive programming. Yeah, it's better than Python in some ways, for sure. There is, of course, like just the raw execution speed, but also I think some of the libraries, once you get the hang of it, it's like there is a bit of a learning curve. But once you get the hang of it, things do tend to be arguably more natural when you do things in C++. But for certain things, I think Python is just quicker and simpler. And for instance, in problems involving large numbers, lots of things that you don't have to worry about. You don't have to remember to use the right types. You won't run into issues because of that. You might run into issues because of the logic not being fast enough. And that's a different story. And that's going to be a challenge with any programming language. If you have an inefficient algorithm, the language choice is not going to save you. It's very, very rare that you have a problem where an inefficient algorithm in C++ will pass, but the same algorithm in Python will not pass. So usually the test cases are not designed like that. So if you have an inefficient algorithm, you have other problems. It's not the language. So sometimes knowing both C++ and Python, which I think some of you are in that situation where you know, or you're trying to learn one and you're already comfortable in one. When you get to the point where you kind of know both, you can just use the best language for the job in terms of what is quicker to type out. And I think that's also an advantage. So it's pretty cool to be in that situation. Okay. All right, I'm just going to request everyone to be on mute by default, and if you feel free to unmute yourself if you have a question, but otherwise it just makes it easier if you're on mute by default. Okay, so in a programming contest, I'm able to solve up to question C. Is this level good enough to clear the final exam with a good score? This is a question from Amitesh and Zoom. I think, well, it also depends on the kind of topics that you're comfortable with, Amitesh. I think sometimes the kind of topics that we cover do end up as being problems that can potentially be harder than level C. So for instance, later in the course, we talk about flows. And we do talk about dynamic programming. In the previous edition of the course, the dynamic programming topic was limited to some very simple examples. So I would say that's just level 0 dynamic programming. For this edition of the course, I'm hoping that we will be able to go further. So I'm working on covering a little more within dynamic programming. So some of these problems that come from, particularly from flows and spanning trees, shortest paths, and dynamic programming in this course. So mostly these are topics from the second half of the course. They typically could potentially be D&E level problems in code forces. And some of them, yeah, I think some of the problems in the finals last year were inspired from code jam problems that were probably a bit harder than level C questions. But you're just starting out with the course. So if you're already able to go up to level C, then I think if you just keep at it, then by the time you reach the end of the course, I think you should be able to be in a position where you do well in the exam. So it's also more than just the level of the problems. I think it's also about just knowing these topics and concepts and being able to apply them. So I hope that helps and that makes sense. Yeah. So let me know if your question is addressed or if you want me to talk more about this. But yeah, the flip side of this is that hopefully once you do the course and you're comfortable, I think we should ask people who did the course last time if this is true. But my guess is that if you're able to get to a point where you're comfortable with all the topics of the course, hopefully you can also go beyond level C when you are in contests. Of course, there is, okay. Sorry, I'm just going to mute Samiksha. Sorry, I think I had to, yeah, to mute you there. Okay, I'm just going to move on to the next question here. I'm doing competitive programming courses, planning on writing exam only. Will you be able to retake? So most likely the competitive programming course will be offered again in the next semester, as far as I know. In any case, these courses are usually offered at least once a year, but I believe this one will very likely be offered every semester. So you can simply retake this next time in terms of writing the exam. That should not be a problem. So especially for anyone who is trying to learn programming and competitive programming at the same time, I think that can be a bit too much. And similarly, if you're trying to learn algorithms and CP at the same time, it can be a bit stressful. So if you want to split it up and do the prerequisites first and then come back next time, that's probably a good idea. So yeah, we're definitely going to be around. In any case, the materials are available on the website. You can learn that anytime you want. But if you want the certification from SWAYAM or NPTEL, and if your question is, will it be offered on this platform again? My answer would be almost certainly yes. For next semester and next year, I think for sure, but also next semester. Okay, so I don't know if we have already killed 7 minutes here. Let me check if. So Tejas, is this the 2 to the n versus n squared question that you were asking in the beginning?
What?
The ad coder contest.
The ad coder contest, the exponential or quadratic. It was a question actually.
Yeah, exponential versus quadratic, right? That's 2 to the n squared. Okay. All right. So okay, at least that's a problem statement that I can parse quickly. So so how did you try to solve it?
First, I did the brute force method, which was if it was, I just did the equation itself and said print yes or no. Then I realized after looking at the question again that the numbers were too big.
Right.
So then my next attempt was to go on my book and paper and write down the possible test cases. And I noticed that any number where n is below 5, they always won't work. So 2, 3, 4, they actually don't work. Whereas 5, 6, 7, and 8, and if I kept on going, it kept showing me that it was true for this case. So then the second program I tried was if n is greater than, ironically greater than 4, then it's true, otherwise it's false.
Okay.
I guess no. And that still didn't work actually. So then,
Oh, okay. That didn't work. Let me just think about why that didn't work.
like the test cases they gave it worked, but then when I submitted it, it's sure it's not the correct answer.
Let's see. So you're definitely right that anything, if n is at most 4, then it is true that 2 to the n is not greater than n squared, and you can just verify that by writing out the examples. But on the other hand, if so, you could, for example, take log on both sides. I guess you get n greater than 2 log n, which is, I mean, okay. So let's see. Yeah, so my approach to this would actually be pretty much the same as what you have in mind, which is that if n is strictly larger than 4, then 2 to the n is indeed bigger, and otherwise it isn't. It seems to be. Yeah, you're right. I just submitted that program, and it does seem to give a wrong answer on one input. I don't know if there's like a corner case that we're missing here. It's an integer between 1 and 10 to the 9. So 1.
I did not test for 1 actually.
Okay, I think you should probably test for 1. I cannot think of else that would make this. So if n is greater than 4 or n is equal to 1, let's try that. The sort of thing usually is a corner case issue because, yeah, I think that works. So you have to test for 1. Sorry, that's just like that's the only thing. So for n is equal to 1, 2 to the n is 2, and n squared is 1. So so when n is, yeah, for n is 2, 3, and 4, the statement doesn't hold. It always holds when n equals 1. And once you go beyond 4, once you go 5 onwards, the exponential grows way faster than n squared. Like if you plot, then you just see that it's running away. You could also like do some calculus thing to convince yourself that that's I mean, so these are both yeah, I mean, I think once these functions are separated, they're going to remain separated, and in fact the gap between them actually grows quite a bit. So as like as I was very surprised when you said that doesn't work, but yeah, I think so what you had in mind was the right it was the right approach. It was just testing for one. Yeah. Okay.
I forgot the corner case.
Right?
I forgot it for 1. Seriously.
Yeah. It's just missing the test code.
Thank you.
All right. Sorry, Kushagra, I think I didn't realize that I wasn't sharing.
तीसरे कल बेटी पास मैं भी इंग्लिश समझे ये सब जानने समझने के लगता चाहिए जो तेरे पास नहीं मेरे पास है सुनो तो मैं क्या बोल रहा हूँ बात सुनो अगर वाकई तुम्हारे 1 करोड़ रुपए का उसको पैसा दे
All right. Yeah, you got the question, Kushagra. Great. Question E from the same contest. Yeah, Nishant, I think if you implement that directly, I'm not sure if it will time out. It might time out because some of, like, if you are trying to raise 10 to the 9, like if you're trying to raise 2 to the 10 to the 9th exponent, then that might be a bit expensive. Yeah. Okay. Fine. So problem E from the same contest. I'm really not sure about whether that's going to be within like the range of what I can solve, but let's see. So now maybe I can share my screen. I want to figure out a way to share my screen and keep the chat open at the same time. Shri Vaishnavi, this is at Coder contest number 238, which apparently just got over. Let me just check if we have questions on YouTube. I think we do, so just give me a moment. All right, a very good evening to everybody, of course. Java or C, what to start for learning Python? To learn Python, you just start with Python, I think. But if you meant Java or C, which language to start with for competitive programming, we've discussed this before a little bit. I think you can really pick whatever language is comfortable for you and shouldn't make too much of a difference. Now, is it necessary to submit the practice assignment? No, it's not graded. I'd recommend doing the practice assignments for practice, but you don't have to submit it. What are the math? Okay, can I request people to not draw on the screen? Thank you. And now, guys, I have to figure out how to clear annotations. Okay. All right, so friends, can I request you to not annotate the screen, please? Oops. Okay, now I'm annotating, even though I don't want to. All right, what are the math I need to learn for competitive programming? Yeah, there's, I think, quite a few math topics that you might want to pick up for CP. Usually, topics related to number theory and specific things like. Okay, can I just request everybody to please not annotate the screen? It's just, yeah. Thank you. Yes, I just don't know if I have the if I'm able to turn off the annotations, so I can maybe request the host or the admin to do that, but it's, yeah. Yeah, I think Kushagra, it's possible that people are doing it by mistake, like I'm doing it now without intending to. I think some people may not realize that they have annotations turned on. So it's okay, I'm just requesting people to be a little bit careful about it. So yeah, thanks. And yes, Sarthak, I don't think I have access to the permission settings because I'm not the host for this meeting, but okay, maybe I actually am a co-host. So yeah, I think I can disable annotations. Thanks for that suggestion. Yeah, cool. All right, so all right, 238 problem B is pizza, and this is comment about the editorials are out, you'll understand it from there. Yeah, always a good idea to get to the editorials after you're stuck for enough time. But okay, so there's rain, sounds, and pizza that has come up. Let's just take a quick look out of curiosity. So we have a circular pizza. You're going to cut this pizza using a sequence A of length n according to the following procedure. Make a cut from the center in the 12 o'clock direction. Next to n operations. Rotate the pizza AI degrees clockwise and make a cut from the center in the 12 o'clock direction. Okay. Fine. So 90, 180, 45, and 195. Okay. So let's see, this 90 degree is kind of clear, right? So you are rotating clockwise 90. So once you rotate clockwise 90, you will just have this line here. In fact, now maybe I should try to annotate so that I can maybe, talk about this. Yeah, so after you rotate 90 degrees, this is the only cut that is there. And now you want to, now you want to make a cut towards the 12 o'clock. So you make that cut. And now you rotate 180 degrees again clockwise. So when you rotate 180 degrees clockwise, then what happens? Then you have these two cuts here. And then again, you cut to the top. And then you rotate 45 degrees, which is what about half of a 90 degrees. So you rotate it just a bit. You rotate it that much, roughly. So you get these three here. I'm just trying to erase the 90 the 12 o'clock cut out of my mind because I'm finding it a bit distracting. So let's see. So after this 45 degree thing, these are the two cuts that you see, and then you make this cut. And then from here, you can rotate 195 degrees, which is, what is 195? It's like rotating 180 degrees and then a little bit more. So again, these are the cuts that you will see. That this is what will happen to these four cuts after the rotation. So you can see that, central, yeah, it's actually 1 second. I don't know if I fully understand how this is a 195 degrees rotation. Yeah, this has come down by 15 degrees. I think the original cut, this line was probably like here. Okay, let me try to see. Yeah, if you rotated this 180 degrees, then what would happen to this red line? It would end up pretty much being I was going to say being mirrored, but I don't think it's exactly like if mirrored is the right word. If you're doing 180 plus 15 degrees, like plus a little more here. So you can try to trace what's happening to this line. What's happening, oops, sorry, just use straight lines for this. So what's happening to this line is that after this rotation, it's kind of ending up here. Does that make sense? That's where the 12 o'clock line is ending up after, after the rotation. And therefore, let's say, this line here has ended up here. This line, of course, is the one that's diametrically opposite to it. So I think it makes sense that that's gone all the way. Yeah. After 360, it'll start reducing the already covered area. Yeah, I think the 360 rotation is the same as like you can mod out multiples of 360, right? I mean, so if I tell you to rotate by, let's say 360 plus 90, for instance. So that would be the same as a 90-degree rotation. So if somebody tells you to rotate by 450, then that's the same as rotating by 90. Okay, then I think this is the last transformation. Yeah, this kind of stop short. Yeah, makes sense. All right, so at least the process is clear. Now let's see, what you have to find is the center angle of the largest pizza after the procedure. It's interesting. So here, for example, so maybe I'll clear the annotations now because this is okay. And so here it is 120, 359. So if you look at the constraints, n is at most 359. AI's range between 1 and 359. So in fact, 360, like no individual rotation is more than 360 because, as I said, you can mod out the multiples of 360 from any rotation. So I think this is, yeah, this is anyways at most 359. There won't be multiple cuts at the same position, and there is no, I was thinking that maybe there's even a guarantee that the sum of the AIs is at most 360, but that's not the case. In fact, I think even here already you have rotated more than 360. So I think the idea is to do a direct simulation here. I can't. Okay, you added all the elements mod 360. Yeah, I think all the elements are anyways at most 360. So maybe you don't even have to do mod 360. And you took the max difference between two adjacent elements of the set. I see. Does that work? Like in this example, for instance, what would you get? 90, 180, 45, 195. Okay, Nishant, you're thinking about linked list, meaning you'll put these angles in the linked list. Is that what you're saying? Yes. Okay. Yeah, I think what you want to really keep track of is when you're drawing the line after a certain rotation, which angle is it? So there's some number which is getting replaced by two numbers, right? I mean, when I draw, for instance, what was happening here was that you had a 90-degree angle. Excuse me. What was happening here was that you had this 90-degree angle, which and then you have this other bigger angle right here. So after the rotation, what happened was that this bigger angle here got intercepted. So right now you are tracking one angle which is 90 and the other which is whatever, 360 minus 90. What is 360 minus 90? It's 270. Yes. All right. So you have 270 and that angle is kind of getting split by this line into 180 plus 90, right? What is happening here is that you had a 90 angle from the previous step, and this angle is splitting it, I think, equally into 45 and 45. So those are the numbers that you're getting here, right? So at any stage, what is happening is, so you can think of maintaining a list of the angles that are generated by the cuts. So initially you have only one number, which is 360. After this step, the 360 got split as 90 and 270. After this, the 270 got split as 90 and 180. Then, you looked at 90 and that got split as 45 and 45. And here, the angle that was getting split was this 180 angle. So this 180 angle is getting split, and it's getting split as 120 and 60. So it doesn't always get split in an equal way, but it gets split into something that was the sum of the two parts. So in every step, what is happening is that in your list, you're taking one number, Z, and you're replacing it with two numbers, X and Y, where X plus Y equals Z. So you seem to be kind of, so that's how you keep track of the angle. So the main thing is to figure out really how the angle is split, what is the proportion. Once you figure that out, your list at the end really reflects the set of angles that got generated at the end of the procedure, right? And then you simply return a max of this. So actually, even a simulation-based thing, a direct approach, I think it's some effort to figure out which is the angle that is getting split and by how much, right? So, okay, let me clear these annotations and get out of the. Yeah, so the max difference between two adjacent elements of the input list, that I'm not sure if that would work. Like in particular, I don't think it works in this, even the sample example that's given. So we may have to refine that idea a little bit. Okay, so Nishant, what you're saying is 90, 180, 45. The remaining angle is 45. The next pointer will be at 45. Yeah, okay, so correct. So I think. Okay, Kushagra, if we see it's just the angle at the top moving backwards and cutting some angle and splitting it in a smaller one. That's yeah, that is kind of true. If you have a certain set of cuts, like you have a list of angles, if you can, I think, yeah, so Amitesh is already suggesting this. You want to track the angle that is at the top. When you rotate by a certain amount, it's really about which angle is now getting targeted at the 12 o'clock position. So this is where it's probably helpful that there are no multiple cuts at the same position, right? So, okay, Aval, we'll take a look at your submission in a minute. Let's just try to think about this, like reason about it from first principles to the extent that we can. Maybe, I don't know, Amitesh, if you're typing out a second step, then feel free to do that. But yeah, essentially, I think, yeah, this is nice because I think it's just a matter of, you have, okay, so I'm giving you a list of angles. So for instance, let's look at the list of angles here. What is that going to be? So here we have, for instance, 45. Okay, apparently I can't modify something I've already written. So this is 180. This is 45. And this is 90. So you have this sort of a, yeah, I think somebody mentioned a linked list or a circular linked list. You can implement this however you like. So I will start from the 12 o'clock point and go clockwise. And yeah, okay, I think so. Okay, okay, so I will let me just come back. Okay, so sum of all the angles mod 360 as you are, I think, going through. Okay, so somehow when you summarized your method initially, I thought you were summing the input angles, but maybe you're doing more. Right, so just to finish, I think what we were trying to say here, you have this list, which is 45, 180, 90, 45, and then I tell you to rotate it by a certain amount. Then you need like a simple thing which tells you what is the slice of pizza that's coming up for the next cut, okay? And by how much is it going to get cut, right? So here, for instance, you have 195, so you're going to, so you're going to basically, you're going to have to look at the longest prefix whose sum is at least 195 but has not, like, so you want the shortest prefix whose sum is at least 195. Does that make sense? That'll give you which piece is getting cut, right? And then I think if you subtract the previous prefix from it, that'll give you the amount by which it's getting cut. Does that make sense? At least to summarize the direct simulation based approach. Does that, let me know if that makes sense. So you have a list, and you can maintain the prefix sums, and you basically want the shortest prefix sum that's bigger, at least 195. And then if you subtract the previous prefix sum from this one, so then you probably, okay, so another previous prefix sum from that one, you subtract 195 from the current prefix sum, that will give you the two new numbers that you're looking for. Let me know if that makes sense. And in the meantime, let me just check if there are any questions on YouTube. How important is it to improve our typing speed in CP? Okay, I think it's useful to be like good with typing speed, but it's something that'll get improved as you practice. I don't think you need to practice it separately. Okay, so any comments on whether the simulation-based approach makes sense? And then let's take a look at, let me clear the annotations again. Yes, oh, okay, new code is here. Oh, I see. Okay, so so again, this is like cumulative sums, right? I think I missed that. Okay, so you're saying sum of all the angles mod 360, but you're taking the sums iteratively and then maintaining the cumulative sum, right? Or in other words, I think what I meant to say was that because you're taking the sums iteratively, you are essentially maintaining cumulative sums. So let's see. Okay, can you so Aval, can you share here what would your sequence look like on this example? So the part that I just wasn't completely sure about was where you say current is current plus I mod 360 and you're inserting current. So don't you get things like 90, 270 and so on? Okay, I should make sure that I'm still connected. So can you give yeah.
And I have one approach, can I say?
Yes, please.
Okay, so ma'am, what I see is that, as I said, that the cut on the upper set is moving backwards, right? So what we do is we keep the track at which position our cut location is. So in the first case, it was at 0. Then we turn it backwards 90 degree.
Okay.
So we got a cut right there. That is in the second circle. Then we mark the location where it is. So the next cut will be this plus the previous cuts plus the current cut. So we take it backwards, and if it comes negative, we just add 320 to 360 to it. So it comes positive.
So you're always adding, right? So how will it become negative?
And we are taking it backwards, right? I mean, sorry, not adding it, just subtracting it.
Oh, I see. Okay, sure.
Yeah, we are moving backwards. So, like first it was a straight line, then it uh, kind of goes 90-degree in backwards. If we see every circle, if we rotate it in any degree, the cuts are same, right?
Correct.
Yeah, the biggest angle can be anything. I'm not getting how to explain. I'll get to you on this on Discord, and please let me know if my approach is correct.
Sure. Yeah. Please
Yeah.
feel free to post either your code or just your approach in English, and we can discuss it there. And
Okay.
you're saying, yeah. So, and just going back to, I think some of the other comments in the chat. But yeah, thanks for sharing that. I think. We just need to make cuts at cumulative sums of angles. This I agree. I think there is definitely some sense of tracking cumulative sums here because, even when you're just trying to simulate the process, that's what comes up, right? So let's say I give you a set of angles, set of cuts that have already been made in the order in which these angles appear. And I tell you that you have to rotate by a certain amount and make the next cut. Then really I want to know what is the smallest prefix sum that exceeds that cut. So there's definitely something in the spirit of cumulative sums, even if you just try to do a direct simulation. So, okay, so you're saying you're just tracking the points of the cuts. So 0, 90, 270. Okay, so you're just doing this without rotating the pizza. You're trying to find the markers where the cuts happened. Okay, that makes sense. So if we were to do it, yeah, okay. So let me just try to go over your approach here. So we keep the pizza fixed. That's in the first picture. The first cut anyway happened. The second cut happens after rotating the pizza clockwise and making a 90-degree cut. So when you do that, you're physically cutting here, right? Or you're physically cutting, okay, so this is not counterclockwise, clockwise. Sorry. Like really bad with angles and things like that. But is this where the second cut happens? Because you're rotating 90 degrees clockwise and then making the 12 o'clock cut, right? So somebody confirmed that that's the first cut. Okay, good. And then from here, okay, perfect. And then from here, you rotate again 180 degrees. And then make the next cut. So that's going to be, so when you were saying 90 to 70, I think that's what came up from like, that's what came up when you were speaking as well, right? So you're subtracting 90 and now you want to subtract, well, so that you've gone back another 180. So overall the angle is 180 plus 270, but counterclockwise. 180 plus 90, which is 270. So 270 counterclockwise. So I guess this would be the next cut. I think it may be useful to color code the cuts so we remember which one is which. Sorry. So this is like, that's the first cut. That's the next one. So yeah, so you're doing cumulative sums in this sense. This is fine. For the next one, it's another, like you go back another 45. So I guess your overall thing would be 315, but counted again counterclockwise. So I guess it would be this one. And then another 195. So, and that is why you need to mod out by 360 at this point. So this last cut is going to be somewhere I'm sure I won't get it right, so don't know if I should bother, but yeah, okay. So, so 510 amounts to 150 going counterclockwise. So this is somewhere here, I guess. Somewhere here, I think. Yeah, it's not very precise, but okay, those are the cards. So those do give you, I think those do give you the final numbers of, yeah, so I think this is similar to what you were saying earlier. So you keep track of these numbers. They give you the points where the cuts happened, and then you can just return the maximum consecutive pairwise difference, because these, yeah, I think that does make sense. You don't need to, do you need to sort these numbers, or because this is like you follow along and you mark where all the cuts happened. Right, okay, sure. So this is, okay, this is like a slightly less, I mean, okay, we're still simulating the cuts, but this is like, I think, doing it in a nicer way compared to like the approach that I was suggesting, which was more of a like really a direct simulation. Yeah, I think if you sort it, you get the markers in consecutive, like you get the consecutive markers, and then when you take the differences, you get the pairwise differences. I think that makes sense. So this process here, taking the cumulative sums and modding out by 360, gives you where the marks are happening. When you sort them, you get the marks in consecutive order. And then you take the consecutive pairwise difference, you get the angles, then you return the max, you get the answer. Yeah, pretty cool. Okay, give me a +1 in the chat if this made sense and you agree that this works. And thanks to everyone who solved it. Yeah, great. Yeah, so okay, so I should probably, if I scroll in the annotations, kind of lose sync. So let me clear the annotations first. Okay. All right. So the other problem was problem E. I'm not sure that we have like enough time to figure this out completely, but let's at least try and take a look at what the problem statement is saying. So you have a secret integer sequence with n elements. You want to guess the contents of the sequence, and you have the value of certain segments of sums. Okay. All right, let's go over a few examples to make sense of this. So you have a sequence of 3 numbers. Okay, you don't know what these sums are. You just have to figure out if it's possible to determine the values of the sequence or not. So if you're given the sums of 1 to 2, 2 to 3, so this is L and R inclusive, I guess. So, so from 1 to, you know, A1 plus A2, I guess. Then you know A2 plus A3, and then you know A2 plus A2. Right. Okay, so here, how do we find the elements of the individual sequences? Well, you already know what A2 is. I guess you could subtract that from the first and the second sums to get A1 plus A3. Does that make sense for this example at least? Yes, Kushal, it would be nice if you could try to implement it as well. That should be good. Yeah. All right, yeah, now we're talking about these range sums. Have some interesting constraints here. We'll get back to that. But here, is it clear why sample output 1 is yes? Give me a +1 if that made sense. Oh, okay. Actually, also I should be careful. Is it possible not to determine? Oh, okay, sure. I cannot post links in YouTube, so this is @coder contest number 238 for those who are watching on YouTube. I should take back what I said about explaining sample input 1, because I thought the question, and this is also where I think it's important to read the question completely. So the question is if it's possible to determine the sum of all the elements in A. It's not about determining each of the individual elements. So those could be two slightly different things. So, but sample input 1 is still a yes, because you know what the second element is, and the sum of the first two sums, which is A1 plus A2 and A2 plus A3, gives you the sum of all the elements plus an extra A2, but you can subtract the extra A2 because you know what it is. Okay, all right, that's fair. Now you have a sequence of 4 elements, and you're given the sum of the first 3, the first 2, and the second and the third, which means that you have no information about the 4th element, right? So the 4th element could really be anything, so you can't really infer that from here. Okay. What about here? Well, 1, 4, and a sequence of length 4, so this is fine. Okay. This feels like there's some XOR kind of business here. I'm not completely sure though. It seems like if you look at all the ranges, definitely one easy prerequisite. So what is coming out from the examples is that every element must appear in at least one of the ranges. Otherwise, you definitely don't have enough information. The other thing is that if somebody gives you the sum of the full range, then you trivially have the answer. It's very easy, right? Because the answer is actually being given to you. So that's always a yes. So the interesting things are like in between. So for instance, suppose I give you, in this example, suppose you didn't have 2, 2, right? Suppose you didn't have 2, 2, then every element is covered, right? So in some sense, you have the information about A2, it's hidden in the sum of A1 plus A2 and the sum of A2 plus A3. But if you didn't have the value of A2, you wouldn't know what to subtract, right? So you don't have the full range and every element is covered, but still, I don't think you can figure out the sum, because the sum could still be anything, right? So, so for instance, if the first value was 50 and the second value was 50, it could be that A1 and A3 are both 1 and A2 is 49. But it could also be that A1 and A3 are 2 and A2 is 48. So it's, and the overall sums would be different for these two examples, right? So in the first example, the overall sum, I think, would be 49 plus 1 plus 1, whereas in the other one, it would be 48 plus 2 plus 2. And those are different numbers, I think 51 and 52, something like that. So you really don't have enough information, and if you didn't have 2, 2 here, okay? So it's at least the problem statement is that clear to everyone? It's like what is being asked and what are some easy cases to discard? Okay, all right, thanks, Kushagra, that's useful. So one thing that we can figure out for each number is if it, like, how many times does it appear in, like, what is the number of times that it appears in these ranges, right? So in this example, 1 appears once, 3 appears once, 2 appears thrice. In this example, 1 appears twice, 2 appears thrice, 3 appears twice, 4 does not appear at all, right? I guess here, yeah, let's see here. I think everything appears once in 1 to 4. and then they appear once on their own. So every element appears twice. Okay, so so one question is if you can figure something out by cancellation. I think we'll need to think about this a little bit more, but it seems like a really fun puzzle. So thanks to whoever shared it. And I think I was a bit concerned about whether whether we have the tools to do this or not based on what we have learned in the course until now. So yeah, I'm not sure if this requires like some specific technique or whether we can just do it from first principles. So yeah, given that we have like a couple of minutes left until the hour, I would say let's try to think about it a little bit more. And maybe we can just, for whoever is interested, we can maybe do like an informal voice meeting or just a discussion on Discord to try and figure this out. I think, yeah, somebody mentioned that the editorials are out, and of course you could, I mean, absolve by trying to take a hint from the editorial, but this looks like a fun enough problem that it's worth thinking about it a little bit before we spoil it for ourselves. So let's do that, everybody. Yeah, and we can connect back on Discord to continue the discussion. Yeah. All right, nice. Tejas, how do we take care of time and memory concerns? I think that's kind of what the whole course is about. And in every problem, we will typically start out by doing some brute force thing. Actually, interestingly, for this question here, I'm not even sure like what's an outright brute force solution. So that's also like, I think that's worth thinking about. Yeah, I think that, yeah, it probably has to do with the question of whether there's some combination of things that we add and subtract from each other that finally leads to every element appearing exactly once. So maybe a brute force thing could be to try all possible combinations, but that's clearly not going to be anywhere close to feasible. So we'll have to think about like, you know, what does it look like from these, you know, from these constraints. Yeah, so yeah, I guess, okay, in terms of how do you take care of time and memory constraints, of course, the first step is awareness, just understanding what the time constraints are. So by looking at the bounds, and I think this is covered in one of the early lectures, by just looking at the bounds and kind of assuming that you have like 10 to the 8, 10 to the 9 operations per second, and you typically have a time limit that's a couple of seconds. By just looking at the constraints, you can kind of figure out like, would an n square algorithm work? Would an n log n algorithm work? Would a linear algorithm work? And sometimes if the constraints are suspiciously small, like you see that n is at most 10 or 20 or something like that, maybe even exponential algorithms are okay, or maybe n to the 4, n to the 5 is also fine. But usually that's kind of rare. Most of the time, what you're looking for is an n squared, an n log n, or an n linear kind of a solution. So that's just trying to figure out which one it is. That's the first step. So look at the constraints and try to figure out what should you be aiming for. That's kind of the first thing. And especially when you're doing DP and things like that, it's also a good idea to look at the memory constraints as well. In a similar way, you can look at what the memory constraint is on the server, look at the constraints for the values, look at how your DP table is coming out, and try and see if it'll fit or not. So the first step, I would say, is some sort of awareness, just trying to set yourself right targets. And then meeting those targets is about knowing these techniques and having practice and experience. So that will come with time. So Tejas, I hope that at least partially addressed your question. Yeah. All right, perfect. So I'm going to stop my screen share here. And I think, all right, this was fun. I wasn't really planning to do anything specific. So thanks so much for the problem suggestions. And I think it was fun to go over like that edge case issue in the very first problem, and the pizza problem was fun to figure out. And yeah, hopefully we can figure out the range queries question as well. If you have any thoughts or ideas, please feel free to share them on Discord, and maybe we can get together and have a follow-up discussion in the near future. And if anyone's watching on YouTube, you know, maybe please join us on Zoom next time. We were nowhere close to the 100 limit in this session, so I'm sure you'll be able to find your way into Zoom next week if you were to try. But nevertheless, thanks so much for joining to everybody, and look forward to seeing you next week. And yeah, this was great fun. So have a great weekend, everyone. Good night for now. And